Hello geometry classes. We are going to go over our guided practice for lesson 11.8 where we're working with spheres, ball-shaped solid figures, and we're going to work on finding the surface area and the volume of a sphere. So we have two theorems. That's where we're going to start with the two theorems. Surface area of a sphere is 4 pi r squared, and the volume of a sphere is 4/3 pi r cubed. So we're going to go ahead and record those and make sure we have them handy so that we can use them as we work through some questions asking us about the volume and surface area of a sphere. Example 1, find the surface area of the sphere. We are given the information that the sphere has an 8-inch radius. So that makes it really easy for us to find the surface area. Here's our formula. Surface area is 4 pi r squared. We're going to put the number 8 in for r because that's a radius, and then we're going to work out our surface area. So surface area is 4 times pi times 8 squared. 8 squared is 64. 4 times 64 is 256. So our surface area is whatever 256 times pi works out to be. I'm using 3.14 for pi. And so my answer for my surface area is about 803.84 inches squared. Notice our units here. We're figuring area. How much wrapping paper would it take to cover up that ball? So that is going to be an area measurement, which means we're going to report our answer in squares, in this case inches squared. Guided practice 1. What is the surface area of this sphere? Well, they tell us it has a diameter of 40 feet and they don't draw it for us, so I went ahead and drew the picture so I could get a visual image of what we're doing. My diameter is from one side of the sphere through the center to the other side. And I know that my radius will be exactly half the length of my diameter. So right here I'm thinking through, if my diameter is 40, the radius is 20. And I'm going to use that radius in my formula. I won't use the diameter. So here's my formula. S is equal to 4 pi r squared. And I'm putting in 20 for my r. And then I'll have surface area is 4 pi times 20 squared. 20 squared is 400. And 4 times 400 is 1600. So I'm going to use my calculator at this point to figure out what 1600 times pi is. And it gives me approximately 5,024 feet squared. Again, this is surface area, so my answer has to be in squares. It is a wrapping paper amount. All right, guided practice 2. The surface area of a sphere is 30 pi meters squared. That's a given, and we're to find the radius of the sphere knowing its surface area. So again, I've drawn the picture of what's going on. They didn't show me the picture. This time, I am told the surface area quantity, and I'm to figure out the radius. I'm still going to use the same formula. I'm just going to be solving for the r this time instead of the surface area. So let's plug our numbers into s equals 4 pi r squared. 30 pi is the surface area, so I plug that in for s. 4 and pi remain, and my r squared is going to just sit in the formula while I start to isolate that variable r. So 30 times pi turns into just 30 when I divide both sides by pi. Those pi's are going to disappear, so I have 30 equals 4 times r squared. Pi's canceled out, they're gone. Then I divide both sides by 4. I have 30 over 4 is equal to r squared. I'm going to go ahead and reduce that fraction. I prefer to work with smaller numbers when I can, and it's easy to reduce that fraction down to 15 halves. So 15 halves is r squared. Now I take the square root of both sides, and I'm going to find out my approximate value for the radius. So the square root of 15 halves is an irrational number, and I'll see lots of digits on my display. I'll round it out to the nearest hundredth. R is 2.74 meters, and that's a good approximation. All right, example 4. Now we'll move into practicing with using the volume of a sphere to answer some questions. And in fact, on this first problem, that's what we're doing. We're finding the volume of the sphere. This is a ball that they show you in your textbook. It's a soccer ball, I think. And they give you the diameter of that soccer ball. It's 9 inches all the way across. My radius will be half the amount of my 9 inches, so 9 divided by 2. You can either write that as 9 halves, 4.5, 4.5, any of those values would work well in this formula. So volume is 4/3 pi r cubed is the formula I start with. I'm going to plug in my 9 halves, or I could have written 4.5. The advantage to writing it this way is that when I write out what this all means, I've got some really easy canceling I can do. So that avoids having to put some larger and longer numbers into my calculator if I want. I don't have to do it this way. I could plug all this into my calculator right now if I want. So I'm going to do the canceling though just to get smaller numbers. So 4/3 stays, pi stays, and I'm writing out what 9 cubed means. It means 9 times 9 times 9. I'm writing out what 2 cubed means. It means 2 times 2 times 2. And then I did some canceling here because I can. And what remains only is 9 times 9 times 3. 9 times 9 is 81. 81 times 3 is 243. The pi is still there. And the only thing that's left in the denominator, not canceled out, is 2. So all I'm going to plug into my calculator is 243 times 3.14 divided by 2, and I'll have my volume approximation here, 381.51 inches cubed. Now we're doing volume, so we need to make sure that our units are in cubes, because that's what we're counting. How many little tiny cubes that are an inch by an inch by an inch could we put into this sphere so that it would take up all of the space inside of that sphere. All right, guided practice 5. Now we're going to be taking a look at finding the volume of a composite solid. That is a solid that is made of more than one particular shape. This particular solid, we are told, consists of a hemisphere, that's half of a sphere, and it tells us the radius of that hemisphere is 1 meter. And that hemisphere is put on top of a cone, and that cone has the same radius as the sphere, and it has a height of 5 centimeters. So if you're picturing an ice cream cone, you got a good idea of what this composite solid looks like. I drew the picture just so I had an idea of how delicious this looks, and I'm asking the question, what's the volume? Well, I have to find the volume of each of those solids separately and add them together. So first I'm going to write the formula for the volume of my cone. Remember, the cone volume is 1/3 pi r squared h. It was a cylinder, it got sharpened down to a point, and only 1/3 of it was left. So remember, our cylinder volume formula is pi r squared h, so we're going to take 1/3 of that. So there's our cone formula. And then for the hemisphere, I'm going to need half of a sphere. Well, a sphere's formula for volume is 4/3 pi r cubed, but I need half of that. That's where the 1/2 comes from. All right, let's go ahead and plug our numbers in. Every time I see r in my formula, I'm going to put in 1. Every time I see h in my formula, I'm going to put in 5. So volume is 1/3 times pi times 1 for my r squared times 5 for my h, plus 1/2 times 4/3 times pi times 1 for my radius. Okay, let's go about simplifying this. So first thing I'm going to do is 1 squared is 1, and that means that all I have here is 1 times pi times 1 times 5. That's just 5 pi over 3. Over here, my 2 and 4 cancel out, so I have 2 over 3. 2 over 3 times pi, and this is going to be 1, so it's just 2/3 pi. So I'm going to add those together. 5/3 and 2/3 pi gives me 7 pi over 3, and that's what I'm going to plug into my calculator. And that will give me a value for the volume of 7.33 meters cubed for that composite solid. Again, that's putting together the hemisphere, the half of the sphere, with the cone. All right, so that should prepare you for completing this lesson now. So it's time to make sure this is on your notes and move on to the lesson work. And I'll see you next time.